a repeated measures or within subjects ANOVA in SPSS. So here I have a SPSS file open, and there are a lot more variables in here before, but I've sort of parted it down to the variables that we need. So I'm replicating here the lecture example, so looking at differences in prejudice between feminists, prostitutes, and lesbians. All right. So we'll go to Analyze, and then we'll go to General Linear Model, General Linear Model, and we'll go to Repeated Measures, like that. All right. And then you'll get this box here. And then it says within subject factor name, and so you can leave this as factor 1, but I recommend changing it to reflect the mean scores that you're working with. So we're looking at prejudice towards different target groups, different social groups. So I'll just put prejudice, and then the number of levels. So we have prejudice towards feminists, prejudice towards prostitutes, and prejudice towards lesbians. So we have 3 mean scores, 3 levels. All right, and then we click Add, and then we click Define, and then you'll see over here where it says 1, 2, 3. These are our 3 different levels. So this is where we're going to put our 3 different scores. So I'll select feminists, I'll select prostitutes, and I'll select lesbians, and I'll bring them over. All right, so 1, 2, 3. And then we'll come over here to the buttons over here, and then we'll click on EM means, and then we'll take our factor, our prejudice factor, and we'll move that over to the display means for box. We'll click compare main effects, and we'll select Bonferroni. So this will give us our post hoc table comparing the mean scores, showing what mean scores actually significantly differ. That is, if we have a significant F value. We'll hit continue, and then under save, just like for the between subjects ANOVA, we'll click Cook's distance, Cook's D. We'll hit continue, and then under options, you want to select descriptive statistics and estimates of effect size. And click continue. And then that should be it. We'll paste our syntax. And then we'll run it. And of course, we will check our Cook's D values first. And you can see Cook's D, we have actually 3 Cook's D values, 1 for each of the mean scores. And then we'll just sort these scores descending. And again, we're looking for big jumps in between the Cook's D values. And there really doesn't seem to be anything to worry about. We looked at specifically this Cook's D in class, where he had the jump from the 0.09 to the 0.05, and while that's a larger jump than we've seen probably with other Cook's D values, it's really not that much to worry about. A 0.04 to a 0.01 difference. We'd be much more worried about, like, if it went from 0.15 to 0.05, that's more of a conspicuous jump, and we'd probably remove that participant, rerun the analysis, and compare the results. But our Cook's D values look good, so it doesn't look like there's any likely outliers. So we would want to make sure we want to ensure that our 3 scores, that the distribution for our 3 mean scores for lesbians, for prostitutes, for prejudice toward lesbians, prejudice towards prostitutes, and prejudice towards feminists, that all of those approximate a normal distribution, and we could check that going on to descriptive statistics, going to frequencies, producing histogram, looking at the skewness value. You would do all that next, and we'll sort of skip over that because that was all under exam 1. I trust that you know how to do that. So we'll go ahead and go to the output here, and as you can see, let's go to the top of the output. As you can see, there are a lot more tables here than we actually look at in class. All right, but the first important table that we look at is, of course, Mauchly's test of sphericity. Now, we want Mauchly's test to be non-significant, just like we want Levine's test to be non-significant for the between subjects ANOVA. Here we want Mauchly's test of sphericity to be non-significant. As we discussed in class, that sphericity is sort of like equality of variance for repeated measures ANOVA, but it's not quite the same, but we really didn't go into detail. But again, we want Mauchly's test of sphericity to be non-significant. Here we have a p-value of 0.014. This is less than or equal to 0.05, our criteria, our threshold for significance. So, unfortunately, Mauchly's test of sphericity is significant. We've technically violated the sphericity assumption. So that means when we look at the test of within subjects effects box, the ANOVA table here, that we are going to use the Greenhouse-Geisser row. Or I should say Greenhouse-Geisser rows. So there are 2 rows for Greenhouse-Geisser. So we're going to pull numbers from those 2 rows. If Mauchly's test was non-significant and we actually met the sphericity assumption, we would use the sphericity assumed rows right here. But because Mauchly's test is significant, we've technically violated the assumption, we'll use the Greenhouse-Geisser rows. And as I explained in class, there are multiple approaches to interpreting a repeated measures ANOVA. This is the safest bet. This is the safest road that you can take. No one should quibble with you about, if Mauchly's test is significant, use the Greenhouse-Geisser correction here. No one should quibble with you. It's a safe thing to do. So just like for the between subjects ANOVA, we're going to pull 5 numbers from the ANOVA table. And they are the DF between, which is in the Greenhouse-Geisser row here, the DF between, which would be 1.88, and then we have the DF within, which is in the error, which is associated with the error term here, which would be 248.28. That's our degrees of freedom within. And then we have our F value, 53.13, rounding. Our P value associated with that F value, we get the triple zeros, so this is P less than 0.001. And then we have our partial eta squared of 0.287. All right, so those are the 5 numbers we need to pull. DF between, DF within, our F value, our P value, and our partial eta squared value. Our F value here, 53.13, is significant because P is less than or equal to 0.05. Our actual P value is P less than 0.001. Because we have a significant F value, that means there's at least one significant difference between the mean scores. That is, between prejudice towards feminists, prejudice towards prostitutes, and prejudice towards lesbians. So we'll take a look at the post hoc table below in just a second. First, I just want to note the partial eta squared here value is 0.287. All right. So again, partial eta squared is an effect size, sort of representing collectively how big the differences are between the mean scores. All right. So for this study, I gave one group of participants, the same group of participants, 3 prejudice measures. And those prejudice measures were all the same except for the target group. So if you remember when we talked about measuring prejudice before exam 2, right? Each participant completed a multi-item scale for each type of prejudice. And then the items read sort of like, generally speaking, I feel negative toward blank. Generally speaking, I feel positive toward blank, right? And in the blank, we either put prostitutes or feminists or lesbians. Right? So this partial eta squared is sort of saying, well, how much did changing or manipulating the target group actually affect participants' prejudice scores? And here, our partial eta squared is 0.287, right? So that is a large partial eta squared that the target group actually explains about 28.7% of the variability or differences in prejudice, right? So manipulating or changing the target group here from lesbians to feminists to lesbians, or sorry, to prostitutes to feminists to lesbians, actually created apparently some big differences that it didn't matter. That changing the target group influenced prejudice scores. Okay. So we will skip this table, and this table, and this table, and this table, and then the table that we want to look at next is the pairwise comparisons table. This will tell us which groups significantly differed from each other. This table looks fairly similar to the between subjects ANOVA multiple comparisons table, right? Except we have pairwise comparisons instead of multiple comparisons. And for the between subjects ANOVA, we actually had labels here, words. For the repeated measures and over here, we have numbers, which is sort of annoying because the first table that SPSS gives you is actually, right? Actually tells us what 1, 2, and 3 actually equal. So 1 is prejudice towards feminists, 2 is prejudice towards prostitutes, and 3 is prejudice toward lesbians. And you could, sorry, I just I just cut this. So you can copy or cut. And you can paste that. Move that up. There we go. So I simply copy and pasted this table from up top down here so we can more easily go through the post hoc table. All right. So if we compare 1 to 2, so this is prejudice towards feminists versus prejudice towards prostitutes. Right, 1 to 2, we see that the p-value is less than 0.001, so there is a significant difference between feminists, prejudice toward feminists, and prejudice towards prostitutes. And again, this isn't a surprise because when we did the paired sample t-test, we compared prejudice towards feminists and prejudice towards prostitutes, and people reported a lot more prejudice towards prostitutes than they did feminists. So we already sort of know this information. We're much more interested in the other two comparisons here to see how prejudice towards feminists compared to prejudice toward lesbians and prejudice towards prostitutes versus prejudice towards lesbians. So if we look 1 to 3, so this is prejudice towards feminists versus prejudice toward lesbians, 1 to 3, we see that the p-value is 0.02. And so this p-value is significant. We have a significant mean difference between prejudice toward feminists and prejudice toward lesbians. The p-value is not as small as less than 0.001, but 0.02 is still less than or equal to 0.05, our threshold for significance. So there's a significant difference between prejudice toward feminists and prejudice toward lesbians. If we actually look at the mean difference here, which is 0.55. This is a positive number, so that means 1, the mean score for 1 must be bigger than the mean score for 3. So participants are reporting more prejudice towards 1, which is prejudice toward feminists, than they are 3, which is prejudice toward lesbians. And then lastly, we have 2 to 3, so prejudice toward prostitutes versus prejudice toward lesbians. And so we go 2 to 3, we look at the p-value here, we get the triple zeros, so p is less than 0.001, so we have a significant difference between prejudice towards prostitutes and prejudice toward lesbians. Now if we look at the mean difference here, 2.06, this is a positive number, so that means the mean score for 2, prejudice toward prostitutes, must be bigger than 3, prejudice toward lesbians. So participants are reporting significantly more prejudice towards prostitutes than they are lesbians. But significance does not equal importance, right? Significance does not equal importance. We have to calculate our D values. And so just like for the between subjects ANOVA, and just like for the independent sample t-test and paired sample t-test, we're going to take each mean difference and divide by S pooled. And we got S pooled for the between subjects ANOVA at least by taking the square root of the mean square error value in the ANOVA table. And we're going to use that same approach here. So we find the mean square error term, and again we're using the information in the Greenhouse-Geisser row. Here in this case it's 3.02. So we're going to take the square root of 3.02. So this gives us a S pooled value of 1.74 rounding, right? So we're going to take each mean difference and divide by 1.74. So we take the first mean difference, 1 versus 2. So this is feminists versus prostitutes. 1.51 divided by 1.74. This will give us a D of 0.87. And again, I'm just using absolute values. I'm just taking the absolute value, so 1.51, because we don't know if the D should be positive or if it should be negative until we actually write up the results. And it depends on which mean comes first in the sentence. So it doesn't really matter, so I'm just going to take absolute values here. So we have 1 versus 3 next, so prejudice toward feminists versus prejudice toward lesbians. The mean difference is 0.55 divided by 1.74. Gives us a mean difference of 0.32. I'm sorry, a D value of 0.32. And then lastly, we have 2 versus 3. And so this looks like it's going to be a big D, 2.06 divided by 1.66. All right. Or no, sorry. It's 1.74. Thinking about another ANOVA that I just did. So 2.06 divided by 1.74. There you go. That looks better. So we take 2.06 divided by S pooled, 1.74. This will give us a D value of 1.18. So prostitutes are not really coming out very well here. It looks like people are reporting a lot more prejudice towards prostitutes than they are feminists or lesbians. And although people are reporting more prejudice towards feminists than they are lesbians, this difference is small. And we can probably see that if we actually do a graph here. So if we go to graphs and we go to chart builder, we hit OK. Make this a little bit bigger so we can see the variables a little bit better. And we're going to go to line, and then we're going to do a simple line graph. And then we're going to take our 3 mean scores. So we have feminists, we have prostitutes, and then we have lesbians, and we're going to move them over. This sounds a little counterintuitive, but we're going to move them over to the y-axis. And we're going to hit OK. We hit OK here. This will give us our line graph. We'll change the scaling here though, because the minimum scale value should be 1, and then the maximum we can leave at 7 probably, and then do a major increment of 1. We'll see how that looks. Yeah, it looks pretty good. Could move this up to 2 if you wanted to. Yeah, sure. I'll do that. Actually, the maximum was 9. Sorry, the maximum was 9 on possible ranges for prejudice were 1 to 9, I believe. But I think this accurately captures the differences between the mean scores. Right? You can clearly see people reporting in a lot more prejudice towards prostitutes than they are feminists or lesbians. And that is the repeated measures ANOVA.